Here's problem 24 from the 2019 AMC 8. In triangle ABC, point D divides side AC so that AD to DC is 1 to 2. Let E be the midpoint of BD, and let F be the point where line BC meets line AE. Given that the area of triangle ABC is 360, what is the area of triangle EBF? You can pause here and solve the problem before seeing the solution. Let's draw the picture. Here is triangle ABC. Point D lies on side AC, dividing it so that AD to DC is 1 to 2. So D is 1/3 of the way from A to C. Now draw segment BD, and mark its midpoint E. Then draw line AE and extend it until it crosses side BC. That crossing point is F. The triangle we want, EBF, is shaded in pink. A clean way to finish is with coordinates. Place A at the origin, and C at 3, 0. Because AD to DC is 1 to 2, D sits at 1, 0. Now choose B at 0, 240. Then the area of triangle ABC is 1/2 times the base 3 times the height 240, which is exactly 360. Just as required, E, the midpoint of BD, is at 0.5, 120. Line AE goes through the origin and 0.5, 120. So its equation is y equals 240x. Line BC goes through 0, 240 and 3, 0. So its equation is y equals 240 minus 80x. Setting them equal, 240x equals 240 minus 80x. So 320x equals 240, giving x equals 0.75 and y equals 180. So F is 0.75, 180. Finally, apply the shoelace formula to E at 0.5, 120, B at 0, 240, and F at 0.75, 180. The area works out to exactly 30. So the area of triangle EBF is 30, choice B.